In this video, we're going to look at why landslides occur in the first place. Now, whether a slope fails or not depends on the balance between two forces. The downward force, which is caused by gravity, and the resisting force, which inhibits sliding. And there's a little diagram. If you're in physics, you tend to draw these things. It's a free body diagram. But it shows you the gravity's constantly pulling everything down, and that's what makes it want to slide and for this whole slope to fail. But there's also things that are holding it where it is that keeps it from sliding. So examples include chemical bonds in mineral crystals. So the minerals themselves hold a rock together to keep it from sliding. It could be cement that holds a sedimentary rock together. Oftentimes it's friction, and that's what holds two different types of rock layers together. So if you have a layer of sandstone with a layer of limestone on top of it, it's pretty much friction that's holding it there. In loose material, it could be electrical charges. This happens a lot in really dry sand, or just friction in between the sand grains. Obviously, if you have kind of small, dry sediment, the more angular the pieces, if you remember that from sedimentary rocks, the more angular the pieces, the harder it is for them to start failing and sliding. If you've got wet material, the surface tension of the water itself can actually hold it together some. So there's lots of things to keep it from failing. Other things that are accounted for in slope stability here. For one, especially if you have regolith, this unconsolidated sediment. The angle of the steepest slope to which granular debris can be piled without collapsing is called the angle of repose. So if you see this little pile of sand, sand stacks up to about 30 degrees. And if you were to go with a tiny, tiny little shovel and dig out the left side of that hill of sand, the top of the hill would slide down and fill in that hole you dug, and it would go right back to being 30 degrees. If it's kind of irregular, large shaped stuff, it can be a little bit steeper, but usually everything is around 30 to 40. And if you remember when we did volcanoes, there's a volcano called a cinder cone. And cinder cones are actually cone shaped because all the pieces of scoria are piled up to the angle of repose. Now, even in solid rock, the slopes can become too steep. Oversteepened slopes can occur by man-made and natural causes. On the top is a pretty famous road cut going into LA. And so that's one of the main ways that humans tend to oversteepen slopes is making road cuts. So what you're going to find is there's a whole lot of landslides that have failed onto roads because of where we stick them. On the bottom is a river where it has been steepened along the way because of the water erosion itself. So we're looking at a cut bank, and you can see that cut bank's fairly young because there's grass overhanging the top. So that's been eroded pretty recently. Here's a beautiful example where a road was put in and greatly steepened the slopes. I believe this is somewhere in South America. I don't know if I would want to do that curve right there, but it gets even worse. This is a road in China. It was actually drilled into the cliff. So they made a little fake cave all the way along the side of the cliff, and I do not think I would trust that. You might remember this location. It was actually in a Cadillac commercial just a few years ago. So slope stability can also depend on a weak surface at some depth below the ground level. So let's look at some of those weakened surfaces. One of them occurs in igneous rocks, such as granite, where your exfoliation joints are parallel to the surface. If you remember, exfoliation happens due to unloading. Granites form deep in the earth where it's under a lot of pressure. When you erode the rocks off the top, that pressure is released and the rock starts to stretch out and expand, and you get exfoliation because of that. And it ends up forming big domes. And one of the reasons why you have domes is because you have landslides sliding down those exfoliation joints. The weakened slope can also happen in bedding plains and sedimentary rocks. Some of the places this happens most commonly is on wet clay layers. Clay tends to be very slippery when it gets wet. It can be on really wet, unconsolidated sand. Or just a bedding plane itself, like a shell bed or evaporite beds. Those tend to just, things slide on those really, really easily. This can also happen in metamorphic rocks, particularly in schist or gneiss, where the foliation is parallel to the surface. If you remember, foliation is an alignment of minerals, particularly those platy minerals like muscovite and biotite. And so those make a nice little surface for the blocks to slide down to. Now this foliation issue actually caused a really nasty landslide back in the 50s. So on August 17th, 1959, in the middle of the night, there was a magnitude 7.2 earthquake near Yellowstone. What that did is caused all sorts of problems in Hebgen Lake, Montana. One of the most famous locations is this landslide you see in the top left picture. You see how there's no trees there? That's because there was a landslide. And what happened there is there were layers of schist. If you look at the geologic map on the right, just below the lake, just south of the lake that's there, you can see this XWBS, that's a biotite schist, and XWM is a muscovite schist. So you have these lovely schist layers, and on top of that was a layer of dolomite and marble. And what happens is that dolomite and marble let water run through, and then you have this, all of a sudden, this really weak sheer plane where that foliation of your schist was, and all of that marble dolomite failed and started sliding down, and that's what led to this slide here, and went down into the river bottom and actually splashed up the wall on the other side of the valley. The picture on the bottom right, where those random people who I have no idea who they were, I just stole this from Google image search, that's actually a boulder that rode all the way across the river valley. It actually didn't turn or anything. It just sort of floated at the top of the landslide. And the reason why they know that is the lichens that were on top of that block weren't damaged at all, so they just rode it. In all, 38 million cubic meters of rock, mud, and debris were deposited at the bottom of this valley. And right in front of the landslide was hurricane force winds, just because of how fast it was coming down, which is just amazing. So all these people were actually camping along the river. There were a couple of campsites here. And so they were all in their tents or the campers sleeping, and they were probably woken up by these winds that all of a sudden hit them at like over 70, 90 miles an hour. And then all the rocks came behind them. There were a total of 19 campers killed by this landslide itself, and there were another 7 people in the area killed because of problems from the earthquake itself. What's kind of sad is there were whole families that were in like 2 tents, and the people in one tent were fine, and the ones in the other tent weren't. So it's actually really sad stories that come out of this. But you can see where the landslide actually blocked the river. When it blocked the river, it created a dam and water backed up behind it. And you can see that in the geologic map there. The water backed up behind it is now known as Earthquake Lake. And if you look at the very left side, or the kind of southwestern part of Earthquake Lake, you can see that QLS, that is the landslide deposit on the geologic map. All right, other things that can change the stability of a slope. Weathering. So rocks break down by weathering. Chemical weathering can break down minerals, and physical weathering breaks apart the rocks, which you see is a granite that's weathered quite a bit. For most of that, you could walk up and put your hand right through it. It's that loose and that weak. So weathering plays a big part here. Vegetation is really important for the stability of a slope because vegetation holds unconsolidated grains together and it can absorb water from the slope, and that's actually pretty important. Um, so places where there's a loss of vegetation actually is at a lot higher risk of landslide activity. And that loss of vegetation can be because of deforestation, by logging or clear cutting, or by fires. On the left bottom here is a series of photo pictures from California. The Thomas Fire burned a lot of Southern California, just north of LA, back in December of 2017, which stripped away a whole lot of vegetation. And when there was a lot of rain during January of 2018, it created a lot of mud flows, in particular in the town of Montecito. And Montecito, there were actually 17 people killed during these mud flows. And that's a direct result of that fire. On the right, that's a little bit closer to home here. This is in Flagstaff. From 2010, we had the Schultz Pass fire. So it's a fire that was burning in between the San Francisco Peaks and Mount Eldon, and that's the area known as Schultz Pass. And so they did a great job, and no structures burned. Unfortunately, afterwards, every time it rained, it created debris flows and mud flows that came in and blocked off the road in Schultz Pass, and into the back of homes in the area. So this is a big problem even after your fire's out, as to what you do to protect against um, the landslides that can happen. And this is something that takes years and years to recover from because you have to have mature vegetation in order to keep things in place. That means you got to plant stuff. Now, water plays a crucial role here. Not every landslide is wet, but most of them are. So water tends to be one of the driving factors. And water can affect the stability of a slope in a lot of ways. For one, it's really heavy. A gallon of water weighs about 8 pounds, and if gravity is what we're working with here, gravity is going to pull on that water pretty hard. So just the weight by itself can make a slope unstable. The other thing it does is a little bit of water creates cohesion. If you think about it, if you got to make a sand castle, you got to get your sand a little bit wet. But if you put too much water in there, your sand flows. And so there's a really delicate balance of just enough water to keep things in place versus too much to get them moving. If you've got wet sediment and it gets shaken, like an earthquake, that can cause liquefaction. And not just earthquakes by themselves. During the Oso landslide, the movement of the landslide triggered a bunch of shaking, which caused liquefaction, which made everything move a lot faster and a lot further than it would have otherwise. Water is also able to erode. It's got a huge erosional potential. And so, particularly on rivers or along the coastline, it can undercut banks and you get collapsing in, which is obviously a type of landslide. The other thing is how it affects the rocks. There are certain rocks that react to water very oddly. So one of the ways it can react to water is by being really slippery. And you can see the pottery wheel at the bottom. The reason why you keep everything wet on a pottery wheel is to keep those clay minerals slippery. And clay is just like a geologic material, right? Clay materials also can swell up when they get wet, and that's what's going on in the little picture on the top. Is this a little pellet of bentonite clay, and you can see when it gets wet just how big it swells up over the course of about an hour or a couple of hours. So if that is a layer of rock underground, you're getting it wet, it's expanding, it's getting really slippery. That can really mess with the stability of a slope in that case. Water also expands when it freezes. We've talked about this a little bit already, right? And this causes frost wedging, and that puts a lot of pressure on rocks. It also creates more joints and cracks in the rock that weakens the structure that could help it fail as well. Now, slope loading is actually pretty important too, because if the top of the slope has extra weight, that can actually cause the slope to fail a lot as well. In this case, this is a set of apartments in Southern California, and you can see where they were doing a lot of work to try to keep the apartment up there, but you can see even the stabilizing efforts working very well, and they ended up having to condemn these and pull everybody out. I don't remember if they tore these down. Sometimes when a house is on the edge of a cliff, they can't even go in and tear the house down because it's so dangerous that you have to just because if the slope's failing, you don't want heavy equipment in there, so they have to just wait and let the whole thing fall down to the bottom, which is actually pretty terrifying. So a lot of these things play into the geology of the area and kind of the general geology. So what you see here is sort of the worst case scenario for an area to have landslides. First, you have layers that are tilted over. The layers are dipping. Right. Second, you have overlying rock that is fairly permeable and a layer of clay that's marked with the number 1 there. That clay-rich layer acts as an aquiclude. And so if you remember, groundwater doesn't flow through clay. So water's going to come down through whatever's above it, and then it's going to hit that layer of clay. It gets the clay really wet. The clay starts to expand, so it picks up the water, the rocks on top of it. Water starts pooling at the top of the clay, which adds buoyancy to the rocks. And since it's tilted over, everything is already ready to slide. Plus, you have this river valley that's eroded the bottom of the slope off. Of course, this is naturally, but it could happen man-made erosion as well. And so we've taken off what the buttress kind of defense at the bottom of this. So in particular, these yellow rocks are just hanging there waiting to slide. And so the left side of the valley here is going to move fairly easily. This is the exact setup that occurred in Grovant, Montana. In 1929, you had a major landslide there, and it actually hit the water and sent a wave of water downstream that actually ended up killing people in that case. So examples of where water's played into these landslides and some of the slope stability issues. If you remember, this is the SR87 landslide we looked at earlier, and you can see the outline of the slope and the slump, and you can see the headscarp pretty nicely. And this is a really big feature. What we know is that this road cut, and you can see like where the road cut is, they took away a lot of rocks. So you can see right above kind of all that yellow heavy equipment. There's quite a bit of man-made erosion here. So we know this is actually an ancient landslide. So we know it's an area that was already unstable and probably shouldn't have a road going through there, but that is an ADOT issue. But a couple days before this happened, this area actually got rain, about 1/4 of an inch of rain. And that by itself was enough to sort of weaken the slope a little bit. And then you had some kind of transient activity, like maybe a big truck went by that shook the ground just right, and everything went sliding. It didn't slide too far, which is good, but it was a slump, and you could see it actually, when it rotated under the road. So you can see kind of the hummocky texture of the road of where it pushed it up. So they had to close this whole thing down, clear out that big landslide, redo the road, stabilize the landslide, and to open the road back up. But my understanding is that every time it rains, even now, this slides a little bit more. So it's an area with ongoing issues. The other one we were looking at earlier is this Arizona 87 landslide up near Page. Nobody was hurt during this, although there were cars passing through at the time, if I remember right. This was sort of in the wee early hours of the morning. This is another one of those cases where it was sort of a terrible place to build because there was a really old landslide here. So the blue line shows you the outline of the really old landslide. It's sort of easiest to recognize it because you can see right above that where it says today's slump, you can see those kind of lots of layers of red. Those should line up with the layers of red that are right above it. And that white limestone at the very top of the ancient large slump came from that chunk of white at the very top of the slope there. So this is another case where there was an old landslide along a cliff and a road cut was made to put in a road, and then we all seemed kind of surprised when the road failed. But we were just looking that nobody was hurt in these things. Now if you look down at the bottom of the picture, this is actually a shot from Google Earth is what you're looking at. it's kind of colorful down there at the bottom. And that's because that is the Chinle Formation. The Chinle Formation is what you find in the Painted Desert, all those really pretty color layers. That's all clay. And so that's a big layer of clay at the bottom of this cliff, which means it's fairly unstable anyway. So the failure is along that clay layer under there, which shouldn't surprise anyone, kind of like the other issues. Now, an earthquake is a transient event that can trigger landslides on unstable slopes. So slopes can be pretty unstable, but not failing. So there has to be some event that makes them fail. And so an earthquake is a great way to do that. These are examples from Christchurch, New Zealand. There was an earthquake in 2011 there. And if you look at these homes, these are some of the worst places to live. I always say do not buy a house at the top of the cliff. Do not buy a house at the bottom of a cliff. And you can see the bottom of the cliff is like covered in boulders, and that's always a terrible, terrible sign. But this actually, the earthquake and the aftershocks triggered a number of little rock falls in the area. This is one that happened. The rock came tumbling down the hill and right through the house and kept on going and stopped really patiently at the side of the road at the bottom of the hill. I just think that one's funny. It cracks me up every time.